Now we're going to look back at the exponential function that we talked about in Chapter 5. If I want to integrate, if you recall, the derivative of e to the x was just e to the x. So we're doing the same thing here. If I give you e to the x and ask you to find the derivative, then you would give me e to the x. So if I give you e to the x as the derivative, and you want to go back to the original function, then once again we just get e to the x. We also want to make sure that we include our constant of integration. So the antiderivative of e to the x dx, that's just e to the x, and then we're going to add c. So if I take the derivative of that, then I get back e to the x. Okay, so for example 12, the first thing I'm going to do is I'm going to bring out the negative 3 that's being multiplied times e to the x. So we're going to bring out that constant multiple. So now I'm going to integrate just the terms that have the x in it, just the part of the term that has the x in it. Well, we already know that the antiderivative of e to the x, so if I integrate that, we get e to the x. We're going to bring down our negative 3, multiply it times our answer, and then we'll add c. So we get negative 3 times e to the x plus c as our antiderivative. Okay, now in the last example dealing with e to the x, we have two separate terms that we're asked to integrate. So we want to keep in mind that what we can do is we can think about this as integrating each term separately with respect to x. So the first term is just 1. So we can integrate 1 with respect to x, plus we can integrate then the second term, e to the x, with respect to x. Okay, 1 is just a constant. So remember that when we have 1 or 2 or any constant that we're asked to integrate, all we're going to do is multiply that by x. So I get 1 times x, and then here the antiderivative of e to the x is just e to the x. So we end up with x plus e to the x plus the constant of integration. This will be really easy to check. If I take the derivative of x, then I get back to 1. If I take the derivative of e to the x, I get back e to the x. And if I take the derivative of this constant, then I would get back 0. So if I take the derivative of my final answer, then I end up right back where I started with that integrand of 1 plus e to the x. Okay, so you can always check your answer by taking the derivative and seeing if it matches the integrand. Okay, now here's a special one. Okay, I'm going to put a couple of stars by this one right here. This is a special one because what happens if I try to use the power rule on x to the negative 1 power? Okay, so we're going to make a little note here. We want to be careful of something. If I give you this and I ask you to integrate x to the negative 1 power, if you try to use the power rule, okay, if you add 1 to the power, then you get 0. And then you'd have to divide by that new power, which means you have division by 0. We are not allowed to divide by 0. Okay, so we're going to have to go back to one of the rules that we talked about a while back. What was the derivative of natural log of x? Well, the derivative of the natural log of x, we know, was 1 over x. So if I want to go back and find the original function that had 1 over x as its derivative, then the answer is going to be natural log of x. And the absolute value symbols here are just making sure that the input for the log function is always positive. And then we're going to add c. Okay, if I take the derivative of this, the derivative of ln of x is 1 over x. And remember that we don't know what the original constant would have been. So we know that if we take the derivative of this, we get back our original integrand. Okay, well, why does it say x to the negative 1? Well, remember that 1 over x is exactly the same as x to the negative 1 power. So if I bring this x to the top of the fraction, change the exponent to be negative, then I get x to the negative 1 power. So if I'm asked to integrate 1 over x, or if I'm asked to integrate x to the negative 1 power, both of these are going to have a final answer of natural log of x plus c. Those are really the same function, just written in different ways. Alright, so put a couple stars by this. Anytime you have x to the negative 1 power, make sure that you don't try to use the power rule. It's not going to work because you'll end up having to divide by 0. Alright, so the derivative of x to the negative 1 power is natural log of x. So this one here, okay, if I rewrite this, and if, let's just say I forget about the rule, and I just rewrite this, and I say, okay, well, this is, have a variable in the denominator, let's bring it out. Let's bring it up to the top, in other words, bring it up to the top. Alright, well, let's bring out that constant multiple of 5. Alright, so if I completely forgot about the rule, and I just started using the power rule, remember what would happen. I would add 1, and I would get 0, and then I'd have to divide by the new power of 0. Remember, we are not allowed to divide by 0, so you would instantly hit a snag, and you would have to stop and think, okay, well, I'm not allowed to divide by 0. This must be that special antiderivative that I have to kind of memorize. So the answer here then would be 5 times natural log of x, and then we're going to add our constant of integration. So that's 5 times ln of x plus c. Alright, so this one you sort of have to memorize and remember what we did in chapter 5, and now we're going backwards from what we did in chapter 5. Okay, now we're going to put several of these all together. So here I am asked to find the antiderivative of the square root of x plus 3 over x minus 2 times e to the x. So we can rewrite this as integrating each of those terms separately. So the square root of x, I'm going to rewrite that as x to the positive 1/2 power plus, I'll make sure that we are integrating with respect to x. Each of those separate integrations are going to end up with their own dx. Okay, so plus. Here I'm going to rewrite this as 3. I'm going to bring the 3 out, and then we're going to write that as x to the negative 1 power dx. So remember, if I have x in the denominator, I'm going to bring that up to the top of the fraction. 3 is a constant multiple that's being multiplied in. And then minus, and I'm going to bring the 2 out for the last term, that constant multiple. And I'm just going to integrate ex with respect to x. Alright, so here I have x to the 1/2 power. I am going to add 1 to the power, which means I'm really adding 2 over 2. So I get x to the 3/2 power, and then I'm going to divide by the new power. So we're going to divide by 3/2. Now keep in mind that as soon as I added 1 to the power, my integration symbol is gone because I've actually done the integration. I don't need to say that I need to do it again. Okay, what about this middle term? So we just talked about this, x to the negative 1 power. Remember, if you add 1 to the new power, you're going to get 0, and then you can't divide by 0. So we run into a problem. So then as soon as you run into that problem, then you say, oh yeah, I want to use that ln of x. So we're going to do ln of x as the integration for x to the negative 1 power. And then here, e to the x, we said the antiderivative of that was just e to the x, which is really nice. Then I could bring down that constant multiple times e to the x. Okay, let's simplify. We said 3/2 power. If I divide by that, that's the same as multiplying by the reciprocal. So I get 2/3 x to the 3/2 power plus 3 times the ln of x minus 2 times e to the x, and then we'll add in our constant of integration. So this will be the antiderivative of the original integrand that we started with. How can I check it? I can take the derivative of this, and I should get right back to the integrand. Alright, for example 17, we actually start out with something that looks pretty complicated, but we're going to simplify this pretty quickly before we start. So we haven't talked about integrating a fraction like this, kind of a complicated fraction. We haven't talked about that yet. So let's simplify it before we start actually integrating. So what I'm going to do is I'm going to take each one of those terms and I'm going to give them back their own separate denominator. So I'm going to say they each have a denominator of t squared. Alright, and I have a radical, the cube root of t, and I'm going to write that as t to the 1/3 power. Now I'm going to integrate these two separate terms. but I can simplify them individually. T cubed divided by t squared is just t. So I'm going to integrate t with respect to t plus, okay, well, what is t to the 1/3 divided by 2? Remember, I do want to bring everything up to the top, so I'm going to rewrite this as t to the 1/3 power. And I'm going to change the exponent in the bottom to be a negative exponent. I'm going to multiply it times the top. So that gives me t to the negative 2 power dt. And let's go a little bit more. 1/3 power minus 2. Let's give them both the same denominator. And let's combine those bases. Remember, if I'm multiplying and I have like bases, then I can add the exponents. So I get 1/3 minus 6/3. And that gives me a negative 5/3 as my new exponent. So we're just simplifying a little bit and bringing those bases, those like bases, up to the top of the fraction, combining those exponents. Like bases, I can add my exponents, and I get something that's much, much simpler to integrate. Okay, so now I'm going to add 1 to the power. So remember, it's t to the power of 1 right now, so if I add 1 to the power, I get t squared. Divide by the new power. Remember, as soon as I do that, my integration symbol goes away. Okay, plus, now I'm going to integrate this. I'm going to add 1 to the power, which means I'm adding 3/3. So that gives me t to the negative 2/3 power, and then I'm going to divide by negative 2/3. And then I'm going to add my constant of integration. Alright, now if you wish to, you can flip that bottom fraction. Since we're dividing by a fraction, we said we can flip the bottom fraction and we can multiply it times the top. So I'm just going to write this as 1/2 times t squared, which is what we have here, and then negative 3/2 times t to the negative 2/3 power plus our constant of integration. Now either of these answers are perfectly acceptable. I just prefer to write them without the division by a fraction. But either of these answers, the answer here in red or the answer here in purple, both of those are perfectly acceptable and would get you 100% credit for the problem on the exam. Alright, number 18, we have a multiplication problem. We have some parentheses going on as part of our integrand. And notice here that we're integrating with respect to u. So what I would like to do is to get rid of the parentheses. So let's get rid of the parentheses throughout the entire problem. So I'm going to rewrite this as, I'm going to integrate there. I'm going to do a distribution. U to the negative 3 power times 10. Well, that's 10 times u to the negative 3 power. Okay. Minus, then I'm going to integrate this part separately. Well, let's wait on that part. Let's just do our distribution. U to the negative 3 power times u to the positive 3 power. Okay, remember when I have like bases, which is u, when I have like bases, we add the exponents. So what's negative 3 plus positive 3? Well, that gives me u to the 0 power. Okay, so when I add the exponents, I get a 0 power. Alright, now let's do the last distribution there. U to the negative 3 power plus or times u squared. Okay, once again we have like bases, so we're going to add the exponent, so that gives us u to the negative 1 power. Okay, and we're going to integrate all of that with respect to u. Now what's nice is that once I have these three separate terms, then I can start integrating them in each individually. Okay, so let's integrate the first term. I'm going to bring out the 10 out front, the first one. For the next one, there's something really nice about this one. What is any base raised to the 0 power? Well, that gives us 1. So now I'm just integrating 1 with respect to u. And then lastly, we have u to the negative 1 power, and we're going to integrate that also with respect to u. So we have three separate integrations. Simplifying a little bit along the way helps make things a lot simpler when we actually perform these three separate integrations. So we're going to add 1 to the power here. That gives me negative 2, so be careful. Negative 3 plus 1, negative 2. Then we're going to divide by the new power. Make sure you bring down your constant multiple that was outside of the integration symbol. Alright, here we have just 1. Okay, remember when we have just 1, we're going to multiply by the variable. So we're going to multiply by u, so that's 1 times u, or just u. And then remember u, or x, whatever the variable is, raised to that negative 1 power. Remember, if I add 1, I get 0, and then I have to divide by 0, which we said we're not allowed to do. So this is one of the ones that we have to stop and say, wait, division by 0, that's a problem. Then we need to remember, oh yeah, we're supposed to think about the ln of x. In this case, of course, it would be ln of u. So ln of u would be the antiderivative of u to the negative 1 power. Then we'll add in our constant of integration. Okay, is there anything we can simplify a little bit? And I think there is. Here we have 10 over 1, and we're dividing by negative 2. So I'm going to write that as negative 5 times u to the negative 2 power minus u plus the ln of u plus c. So here is the antiderivative for all of those terms. Okay, make sure that you're careful here. Anytime you have a variable raised to that negative 1 exponent, you need to be careful about what your antiderivative is.